This is the second part of our lesson on exponent laws. In this part, we're going to go through the basic exponent laws for multiplying, dividing, power of a power, and zero exponents. So when we're multiplying exponents, there's a shortcut here that you would have learned in grade 9. When you're multiplying two things that have the same base, you take the exponents and you add them. So I'm going to do one example just to show you that it actually works, and then we'll do one example where we just try the shortcut. So here I have 10 to the power of 2 times 10 to the power of 3. Now in the previous part we talked about it being repeated multiplication when you have an exponent. So 10 to the power of 2 is just 10 times 10. So I'm going to put 10 times 10. And then 10 to the power of 3 is 10 times 10 times 10, 3 times. And you'll notice what I end up with is 10 times 10 times 10 times 10 times 10. I have 5 tens all being multiplied together. So I can write that that is just 10 to the power of 5 because there are 5 tens being multiplied together. And you'll notice 2 plus 3 equals 5. So the rule does actually work. So let's try it here. I have x to the 10 times x to the 7. So we're going to do x to the 10 plus 7 since it's multiplication. And 10 plus 7 is 17. So that's x to the power of 17. Now dividing exponents, if I have x to the a divided by x to the b, what we do if there's the same base is we subtract the exponents. So I have 10 to the 15 divided by 10 to the 5, and really I have no desire to write 10 out 15 times. So I think I'm just going to change that to a 7. So 10 to the 7 divided by 10 to the 5 would be 10 to the 7, that's 10 times. So 10 times 10 times 10 times 10, I need to do that 7 times, 10, 10, and 10. And then 10 to the 5, you'll notice that I'm doing a dot for the multiplication instead of an X or a bracket just so that it'll fit better. Now what will happen here is that a 10 from the top is going to divide out with one of the 10s from the bottom. And then another 10 from the top divides out with another 10 from the bottom. And another 10 from the top divides out with another 10 from the bottom. And another 10 and another 10 until I'm just left with 2 10s. So this is going to be 10 to the power of 2. And if I tried the rule, 7 take away 5 definitely gives me a 2. So we're going to try that rule on the last question here. So x to the 5 divided by x to the 3. I'm going to subtract. I'm going to do 5 minus 3, which is x to the power of 2. Nested exponents, sometimes known as power of a power, usually are ones that have a bracket. So here we have x to the a, we have a big bracket, and then we have another power of b. So sometimes they're called power of a power because there's an exponent on top of another exponent. Sometimes they're called nested exponents because they have brackets, like they're all in their own individual little nests. And the rule for this is that when you have the bracket, you multiply. So we do a times b. So 10 to the 9 to the power of 2, I'm going to try to prove it with this one. 10 to the 9 to the power of 2 would be the same thing as 10 to the 9 times 10 to the 9, right? It repeats itself 2 times. And we just learned that with multiplication, you add your exponents. So 9 plus 9 would give me 10 to the power of 18. And if I check, 9 times 2 equals 18. So that means the rule really does work. So x to the 9 to the power of 10, we leave the base x and we multiply the exponents. So 9 times 10 would give me x to the power of 19. Now there is a typo on your sheet that I gave you. So if you would like to cross out what was here, which I believe was x to the a times x to the b equals x to the a plus b, and write in the new rule, which is that x to the power of 0 equals 1. So the thing about zero exponents is they always equal 1. We're going to try to prove it with the first one, and then we'll try doing an example on the second one. So 10 to the 0, I'm going to make up a question that has an answer of 10 to the 0. So I'm going to put 10 to the 2. If I do 10 to the 2 divided by 10 to the 2, The rule for division is to subtract. So 2 take away 2 is 0. So that would give me 10 to the power of 0. Now 10 to the 2 is 100, right? 10 times 10 is 100. And 10 to the 2 on the bottom is 100. And 100 divided by 100 equals 1. So the only way you can end up with an exponent of 0 is if you divide something by the same exponent, right? So if you have 10 to the 2, it has to be divided by 10 to the 2. And when you divide something by itself, it always equals 1. So here, y to the power of 0 is just going to equal 1. So in the next video, we are going to do some examples of how to use these rules together.